You've got access to some of the most powerful AI models on the planet. So why do your vibe coding workflows feel like you are fighting the tools instead of working with them? Well, here's the thing. Vibe coders everywhere are using tools like Gemini CLI and Claude Code like they're just another code generator. They give a basic prompt, get a mediocre result, and the whole thing just kind of feels janky. I get it. It's fine to be there, but it is not fine to stay there. So in the next 15 minutes, I'm going to give you 11 Gemini CLI tips that will fundamentally change how you use the tool. We're talking about changing it from a simple code generator to a full-fledged development partner that actually understands you and how you work. So there's going to be no fluff, no 10 ways that I make better prompts type of nonsense, just actionable tips that you can actually use. So make sure you stick around till the end because the tips in this list are actually good. All right, so let's kick this off with something that's actually going to save you money. There are two ways that you can authenticate with Gemini CLI. There's your standard API key method where you are paying per token, right? And you're just watching your requests accumulate like you're paying for a taxi. But why do that when you can get 1,000 requests per day for free? Yes, for free. 1,000 requests per day for free. Here's how you do it. So first things first, you need to have Gemini CLI installed. The command for this will be in the description, but you're typing in npm install -g for global at Google/Gemini CLI, and you will hit enter. So once that's done, we can get into the CLI. And the first thing that you are going to do is you're going to be asked to authenticate. Now, if I were to type in /auth, I can change the authentication method. And so I have 3 ways to do that. I can log in with Google, I can use a Gemini API key, or I can use this Vertex AI key, which probably will not apply to anyone. So if we were to come up and choose the option to log in with Google and hit enter, we'll be able to simply choose our Google account, authenticate, and boom, that is it, and we are ready to go. So on their free tier, again, you get 1,000 requests per day for free. So I love this because it totally kills that like cost anxiety of trying to experiment with things. A lot of people default to tools like Replit or whatever it might be because they know what the costs are going to be. And so this is great because it removes that barrier of entry for a lot of people to start testing and experimenting in ways that they may not have done before. Now, tip number 2 is the Gemini Markdown file. So think of this like a master prompt, right? One prompt to rule them all. These are rules that will apply to anything that gets touched. So it's not just some basic configuration file. It actually has a big impact on how you drive the system. Now, there's a lot of ways you could choose to configure this file, but I have a pretty basic setup here for demo purposes where we have some context about our app, the standards by which we want to develop this app, and different tool preferences that we prefer for different types of scenarios. So let's say, for example, in the context section, we want to provide documentation about our tech stack and preferred choices. So again, basic example, we have a Python fast API service for this scraper that we're building. We want a basic create React app front end with TypeScript so that I can interact with the database and the data and do a few things. And then I want this all running locally with a local Postgres database. So I'm going to tell it all that that is what I am doing. Now for our standards, maybe we want to utilize a test-driven development cycle where we build tests before we build features. Well, I can put that in here, and now when it goes to develop a feature in the future, it's going to know that it first needs to build a test for that feature. Now, maybe under tool preferences, we have specific MCP servers, for example, that we want to use for specific things. So I could come through here, and I could say, use context 7 MCP server anytime you need documentation for external services. Okay, and then I could remove this web fetch. So again, this is going to be passed now like a system prompt through every single time we make a request to the Gemini CLI. And so this is big because we only really need to instruct or teach Gemini how we want to do certain things one time. So no more repetitive prompt engineering and having to say the same thing over and over and over and over again every single time you go to build something. But we can build on top of this idea with something even bigger and better, which is tip number 3. One of the biggest headaches as a vibe coder or context engineer is that you have all of these different prompts that are sometimes getting nested inside of each other. You need to store them in places. You need to keep track of which ones you used. You need to copy them and paste them over a bunch of times into the same project. It gets kind of hectic and gets kind of annoying. Well, similar to Claude Code, Gemini CLI allows you to create custom slash commands. So let's say that anytime we finish a feature or a piece of code, we want to go through the following process. We want to analyze the files, build a series of tests around them if they don't exist. We want to run those tests. We want to fix any errors that come out of those tests. And then we want a descriptive commit message that gets committed. Well, we can actually build our own command to do that. And so everything that we are passing in here from prompt all the way on down to the end of this file pretty much is going to be passed to the language model. And we are instructing it to do exactly that, right? So we're giving it the entire workflow. You need to scan the project, see if there's tests. If they're not there, actually build them. You need to then run the test. You need to then fix any errors based on this specific convention for fixing those errors. After you fixed it, you need to rerun the test. And then after the tests are passing, you need to actually generate a commit message and stage the files. And so now if I wanted to access this, all I need to do is open my terminal, go into Gemini, and just type in slash, and then the name that I gave the command, and we're going to see that we have access to it as a custom command. So the way that we get access to these is pretty simple. Inside of your project, you need a .gemini directory with a directory called commands inside of it. Then inside of commands, you want to add in any of these commands that you want to have. So let's say, for example, we wanted to add something basic in here, like a basic test. I'll just call this basic test. And so now that we have this file, I can put some basic code in here and I can save that. And now if I was to go back out of the Gemini CLI and load back in and type slash basic, we're going to see my basic test is now loaded up with the description of what this does, right? It generates a fix for a given GitHub issue in this case. Now, if you want guidance on how exactly to make these in the format it needs to be in, the Gemini CLI GitHub repository has an entire section where they show you how to create these custom commands. And so you could just use one of their examples, or you could pass this into a tool like Claude or Gemini or ChatGPT and have it use this to build something for you for your specific use case. But let's say now as we commit, and we build, there's going to be stuff that we want to remember. So tip number 4 is memory addition and recall, which is super powerful, and it is going to help you avoid the frustration of having to refix problems over and over and over again. And I'm sure some of you have been there. It's 2 a.m. and you fix some Babel Tailwind configuration issue that was just plaguing you, and you went through so many steps with the language model to fix this thing, and you finally fix it. And then 2 weeks later, you're working on a new project and you run into the exact same error and you see it going through the same exact debugging steps and it's not fixing it this time. And you're just super frustrated because you know you've done this before. And so this is what memory helps you to solve, because you can store facts and decisions that were made and solutions permanently. So in this example, I am building a project that's meant to help me understand trends in YouTube around the topic of vibe coding. And so as part of that, I have this language model query engine where we can understand trends that are taking place and document those things. Now, for development purposes, it's using GPT 3.5 Turbo. Now, let's say we want to upgrade this to 4.0 and we want the system to actually remember that. So now we can come in here and we can say, for example, /memory and then add, and anything we provide as an argument is now going to be added into the system memory. So I could say, for example, for all LLM queries in this app, we use OpenAI GPT 4.0. And I hit enter. And now we can see this has actually been added into memory. And so if I wanted to see now everything I have in memory, I could type /memory show. And if I were to scroll up, we're going to see that it's loaded in all of the context that we had in our Gemini.markdown file. And then we also have this Gemini added memories where we can see any memories that we are storing. So for example, if I was to say, update all of our LLM querying based on our current conventions and hit enter, we can see that it is now going through and it is removing all of the other model providers that we had. We had an Anthropic class, we had a local Ollama configured class, And so what it's planned to do right now is to go through and change all of those, because I said that we're only using OpenAI, right? So it's going through, it's actually scrubbing all of that now out of the tool. So this is pretty powerful stuff. So that memory show command is really valuable, because if we're ever coming back to a project, we can always just use /memory show and see all of the memories of the specific context that we had saved into the system. So it's like having a second brain that remembers all of the critical details of your workflows, and then you can just load that brain into your development process at all times. But even with the best memory, sometimes you still mess stuff up, which is why we get to our next tip. So tip number 5 is the checkpoint restore. And listen, if you're the type that likes to experiment, which if you're watching this video, you probably are, and shout out to you, by the way, then this is critical to those workflows, because sometimes we get a little too ambitious. We get a little too big for our britches, and we get to a point where we really just need to be able to roll things back. And so checkpoints are a safety net that allow you to do exactly that. And so we can see now that this thing is moving and grooving, right? It's creating the different manager file for it. It's updating the vector embedding files. It's making a lot of changes to the project. So let's say I just cancel this halfway through, and now I want to actually roll this thing back. So if I were to come in and type in /restore, and so when we type that in, it's going to give us a list of all of the places we can restore back to. And so it does this based on tool calls that were made. And so, for example, we see this going in order. This was the first change that it made. So if I were to copy that and go back and type in restore now and type that in, it is going to restore us to the point in time where we were about to make that change. And so now we can come back through and not make that change. And now our project has been reverted. So this is like having multiple save slots in a video game, except it's cooler because we're fighting real dragons, not fake ones. So tip number 6 is the TDD cycle, the testing-driven development cycle. So quick aside, one of the reasons I actually love Amazon's new Kiro, I don't know if I'm pronouncing that correctly even, Kiro IDE, is that it has this spec-first integrated testing-driven development cycle inside of the IDE, which means every time it goes to build a feature, it builds a test first. And then after it builds the feature, it makes sure the test actually passes. So at first it was annoying, but then it became not annoying because it means there's a much smaller likelihood of your project breaking. And so before you close the video thinking TDD doesn't sound like vibe coding, you're not even vibe coding. Hear me out for a second. With Gemini CLI, this is actually a faster way for you to get to a functional feature, and I'm going to show you how. So let's say in our task list, we have this task 13 that we have not started yet. So we want to add error handling. So let's say we want to perform this task, which is building a CLI interface for this app. Now, if you remember back in our Gemini.Markdown, we told it that we want it to utilize a test-driven development cycle. And so it should remember this when we go to make this request. And so we're going to go through, and I'm just going to paste in and let it run. And so the basic premise of this TDD, test-driven development cycle, is this. You build a test first. It's obviously going to fail because you haven't built the feature yet. Then you build the feature, and then you run the test. And you see where the misalignment is, and you continue to iterate until the feature is working with the test that you've built. So it's a pretty tight loop. Test, fail, implement, loop. So in the long run, this is actually going to save you a lot of time because you're not going to be spending as much time in the future fixing things that are buggy because you tested them in the first place. So instead of spending hours building a massive feature only to realize that it doesn't actually work, you're getting this constant validation every few minutes of red, green, red, green, red, green, red, green, right? We are building tests, we're running tests, we're iterating on the feature until the tests actually pass. And the big thing, which is huge, is once you actually move to a production environment, you now have an actual testing suite that you can roll out anytime you push a new feature so that you're not breaking your code in production. Now, from what I've understood, Gemini CLI is actually built with a test-driven development cycle in its logic at its core. So it handles that actual iterative process much better than other tools do out of the gate. And so bonus tip, you can add this to your Gemini Markdown file to say anytime you build a new feature, you absolutely must adhere to a TDD, test-driven development cycle. So tip number 7 are the multimodal capabilities of Gemini. I'm sure a lot of you have been there before where you're trying to describe a UI and the problems to the AI. Like, I need you to like fix the button because it's blue, but not that blue, it's too blue, and it should be a little bit more rounded, and you're like trying to describe this thing, and then it just doesn't give you the response that you're looking for. Not super fun if you've been there. We can probably all agree on that. But a recent study that I will link below showed that vision-enabled models perform 200% better compared with text-based models on debugging non-crashing problems with an app, right? So if you're actually using an image of what the problem is, it's going to be a lot more effective at solving that problem than just trying to describe the problem. So let's say, for example, that we have an app like this one that we've worked on in a few different videos. And let's say we want to add a really nice splash screen. We want like a really bold feeling splash screen like one of these. And so we could run through here until we find one that really kind of speaks to us and what we want. So let's say this one from Kraken, we like that, and so we download that screen. So the way that we get access to that is that we type in an @ symbol, and then if we have this project in our directory, we can just select the image, and then we can tell it what we want it to do. Use this as a reference image and take into account the UI style guide of my project to build me a bold splash screen. So this becomes an absolute killer when you want to, for example, automate your bug fixing or automatically fix your UI based on the output that was generated. I did an entire video on that concept of a self-healing UI, which I will link somewhere above here right now. And so imagine creating, for example, a custom slash command called UI healing that can automatically take snapshots of your app, pass it to Gemini, and have Gemini automatically grade that output and fix itself based on its understanding of what it actually built. Now, I did an entire video on this in Claude code, but the same exact principles apply in Gemini CLI. So we can have it grade and grade and grade and grade itself until it reaches a score of an A+. Pretty cool. Which leads us nicely into tip 8, which is file references. So let's say that we want to make a custom command that will go through any new feature that we've built and evaluate it against our UI and our UX guidelines. So again, we can generate a custom command, but the difference is that we are going to paste in or provide specific references to our guidelines. So with this @ symbol that we have here, we can reference other files inside of our project and then tell the system that you need to pull these files in anytime you run this command. So for example, we have this guidelines, UX guidelines directory, and inside it we have this UI markdown file and this UX markdown file, which is explaining how to build UI and UX that looks kind of good. And so it's going to take in that file for UI, that file for UX, and then the specific component that we are trying to audit, and then it's going to give us a markdown response of what it found. And so now we can see as it's going through, it's looking at each piece that we had inside of our guidelines, and it's evaluating what it has against those guidelines. And so it's showing us what is compliant, but then what is insufficient. So for example, not enough color contrast. And so it's giving us actionable recommendation to fix that. Now, obviously, we could do the same thing for anything, right? Database schemas, API conventions, testing conventions, anything that we might have that we would want to evaluate or audit our work against, we can follow the same process. So custom slash commands are super powerful, but especially when they're paired with this ability to reference specific files with that @ symbol, becomes super powerful. But now when you're getting a ton of context and we're loading in some of these files, which sometimes can be really big, we need to make sure we are managing our context properly, which brings us to the next tip. So tip number 9 is knowing when to compress your context versus clear your context. So bad context management typically leads to a few things: slow responses, expensive outputs because it's having to manage all of that context, and then poor quality. So as that context window becomes super stuffed with stuff, we tend to get lower quality outputs. So here's a generally helpful strategy. So if you were switching to a completely new feature, so let's say we just went through and we did this whole thing and now we want to move on to something else, we can just use the clear functionality. So this is going to clear everything. So effectively, we're just resetting what we had there. But now maybe we were really jamming on a feature for a really long time, like we were in this other scraper project that we were looking at earlier, And we're continuing to develop on this, but we know that the context is becoming too big. So maybe if we know that Gemini has a 1 million token context window and we've been using like 300,000 tokens in this window, it's like, okay, it's time to manage that. So we want to remember what's going on, but maybe we don't need every single detail. And so we can use this compress function. And so we can see in this case that it went from 42,000 tokens down to 8,600 tokens. And so what this does is it's going to summarize the conversation so that we still have the context of what has happened, but it's not going to retain all of the details of every single message that you sent back and forth and what happened. Now, according to some people in the Gemini CLI GitHub repository, people are seeing up to a 90% reduction in some cases in the token usage by using this compression function. So that is pretty huge. And what happens typically with something like Gemini is that people get so jazzed up on how big this context window is that they don't take the time to still manage that context and clear out the context when needed and compress the context when needed. You should always be thinking through what details exactly does this thing need to do the next thing I'm about to ask it. And if the answer is that it does not need all the details or it doesn't need any of the details, you're going to save yourself time and money and peace of mind by just clearing out that context or compressing it. So tip 10 is auto-accepting modes. So look, a bit of context real quick. I cracked myself up. I was someone that always wanted to be a product guy, but ended up becoming a sales engineer because I could kind of code and I could actually talk to human beings, right? So I could understand technical solutions, but probably not enough to build them in that type of syntax on my own. I would have had to commit a lot to going down that path of becoming excellent at software engineering, which I chose not to do. Now, there's a reason that I tell you that. There's a big temptation for vibe coders in particular to just auto-accept everything, right? The mythical YOLO mode. But there's a huge strategic edge that you will have in the future if you take the time to at least understand the plan that the language model is unveiling to you. So understanding the details of the plan before we give the keys to the car to the teenager. And so you have 3 options for auto-accepting: none, safe, and all. So none is pretty much the default state where you're going to have to approve everything. File edits, any modifications, tool usage, you have to approve everything that happens. It's like having training wheels on a bike. And it's really good when you're working on things that are very important, very sensitive, mission critical things. Now, the other option is that we can create inside of this .gemini directory a settings.json, and we can use this to configure project level permissions. And so the safe mode here would be setting auto accept to true, which will auto approve non-destructive changes. And so if we look at the documentation, it controls whether the CLI automatically accepts and executes tool calls that are considered safe. For example, read-only operations without explicit user confirmations. If set to true, the CLI is going to bypass the confirmation prop for safe tools. And so to use the bike analogy, this is kind of like one of those bikes that don't have the pedals on them that kids just kind of push themselves along with. Now, when you initiate Gemini through the CLI, you can pass in this flag for YOLO, which enables YOLO mode, which is going to automatically approve all tool calls. So this is like fully automated. You just took that kid off the bike and you put him on a motorcycle and said, good luck. So the AI is going to do whatever it thinks is best. Now, I only use this when I have a checkpoint in place already, and I am very clear about what I want this thing to go do. So it's going to work well if you have like spec heavy or requirement heavy or testing heavy frameworks and systems in place, and then it's YOLOing through a series of tests, for example. That is where it is going to work a little more safely. And so the key is matching the mode to your knowledge, your level of skill, and the task that we have. Now, one of the biggest needle movers when we're battling for the supremacy of language models in the context of coding is the context window size. The biggest thing that Gemini CLI has going for it right now compared with other options is its context window, which is 1 million tokens. Now, that is roughly 5 times larger than the context window of Claude Code. Now, I will say if we were stacking apples to apples, Claude Code is better than Gemini CLI, but Gemini has a lot of other things going for it, like the fact that you can use it for free. And so this is going to be a battleground in the future, having this context window size. This is why there's a lot of talk about Claude Code coming out with other versions that have much larger context windows, but will probably be a lot more expensive because context is everything. So again, for Gemini, with a smaller vibe coded project, you can literally load in your entire production code base and make a query to Gemini. And so the impact of doing that is huge because then it has vision into all of the different moving pieces in your project, and it's not going to make a decision that ends up being wrong because it lacked the full context of the project and how everything was working. So it's kind of like the difference between a junior dev who's, just works on one ticket and is narrowly focused versus the senior dev who knows about everything because he built everything and he knows about this one line in this one file that if you erase that line that no one knows how it works, your entire project's going to crash. So pretty big deal. So yeah, there you have it. Free auth to save money, custom commands to vibe code like a pro, checkpoints to experiment with ease, and a context window big enough to handle your entire code base. What more could a vibe coder ask for? Now, if you want to see how I put all of this together into a production-ready SaaS app, well, stay tuned and make sure you're subscribed because we will be building that stuff out in the future. And drop a comment, by the way, if you think there's any Gemini CLI tips that are relevant for the audience that maybe I did not include. But that is it. I'll see you in the next video.